So the last thing that we have to figure out with redox reactions is what are we going to do when we are not in an acidic solution? What about if we're in a basic solution, which is right here, and I just sort of stopped and I said we're going to come back to this after we've mastered acidic solution situations. If the solution is basic, we're just going to make a minor tweak to the balanced equation. We're not going to change anything. We're just going to add one more step. If the solution is basic, we cannot have H pluses running around because that is what it means to be acidic. So if we actually have a basic solution, after we've added our H pluses, we are going to add OH minus to both sides to neutralize, on paper, H plus. We're going to add enough OH minus to both sides so that we're able to neutralize and get rid of all of the H pluses. So if we have two H pluses on the left side, we're going to add two OHs to both the left and the right side. And this step of what we're going to do if the solution is basic, we can actually do that at pretty much any time in the balancing process, anywhere after we've added the H plus. So we could do it immediately after adding the H plus, or we can wait until the very, very end, or we could do it somewhere in the middle. Like, it kind of doesn't really matter exactly where we do it. So let's practice this whole adding the OH minus thing. It's really not tricky, especially since you already know how to balance the half reactions. And what we're actually going to do is we're going to redo this H2O2 plus Fe2 plus in basic solution following the new steps. We're going to pretend like we don't know what we're doing. So we're doing H2O2 plus Fe2 plus, making H2O and Fe3 plus, and this time we are in basic solution. So first thing that we're going to do is separate into half reactions like this, and next thing that we're going to do is balance our iron. It's already balanced. Now we're going to balance our water. We have balance the oxygen. 2 oxygen on the left, which means that we need to add a water molecule to the right-hand side. So I'm changing that coefficient to 2. Now we're going to balance the hydrogen. We have 2 hydrogen on the left, 4 hydrogen on the right. So we need to add 2 more hydrogen ions to the left-hand side. Now we have 4 on the left, 4 on the right. Because it's a basic solution, now we need to neutralize those H pluses that we just added. However, we don't want to unbalance our reaction. So whatever we've done to the left-hand side, we need to also do to the right-hand side so that the reaction stays balanced. When we say this, we're neutralizing the H plus. That means that the H plus and the OH minus are being combined together to make 2 water molecules, or 3 or 4 or 1, or however many you might have had. So now we don't have any H pluses at all anymore. We just have water instead. So moving on, we need to add electrons to balance the charge in the half reaction number 1. The left-hand side is neutral, the right-hand side is a -2. We need to bring the left-hand side down, so we're going to add 2 electrons to the left side. And for half reaction number 2, we need to add 1 electron to the left side so that they both have the same charge. We need the number of electrons to match in our 2 half reactions. So I'm just going to change those coefficients. And now we're going to put the half reactions together. H2O2 plus 2 H2O plus 2 electrons, 2 Fe2 plus, and our products are 2 H2O, 2 OH minus, 2 Fe3 plus and 2 electrons. We've got 2 water molecules on both the left and the right, so they go away, and we have 2 electrons on the left and the right, so they go away, and here is the equation balanced in a basic solution.